Hi guys, welcome back to Maths with Cats. So today I'm going to be going over modulus or moduli for AQA A-Level Maths. Modulus is singular, moduli plural, kind of like cactus, cacti. So basics. The modulus of a number is the size of the number. It isn't affected by whether the number is positive or negative. For a positive number, the modulus is the same as the original number. But for a negative number, the modulus is its positive value. So how can I explain this? The modulus of 3 is 3. The modulus of minus 3 would be 3. Because it's the size of the number and not whether it's the value, so not whether it's positive or negative. The modulus of a number can be written like this with the two lines, and once again I've forgotten my laser pen. There we go. Yeah, so written with two lines either side. If x is more than or equal to 0, the modulus of x is x. And if x is less than 0, the modulus of x is minus x, because if you think about it, that would mean that there's a minus in here, and then minus of a minus is positive, so that would mean the positive up here. Functions can also have a modulus. The modulus of a function, f of x, is the positive value. If f of x is equal to minus 6, then the modulus of f of x equals 6. So you could say the modulus of f of 3. So you'd put 3 into the function. If you got a positive number out, then it's the same. And if you got a negative number out, you'd switch the sign so that it'd be positive. If the modulus is inside the brackets, f of the modulus of x, then you make the x value positive before applying the function. So f of the modulus of minus 2 is the same as f of 2. Graphing modulus functions. So for y is equal to the modulus of f of x, any negative values of f of x are made positive by reflecting them in the x-axis. So if, we'll call this top line here the x-axis, if you had a curve that went like this bit here would be reflected upwards like this. So it would be a V-shaped graph. For y equals f of the modulus of x, negative values of x produce the same result as the positive x values. So the graph of f of x for x is more than or equal to 0 is reflected in the y-axis to produce the results for the negative values. Sounds a bit complicated. Will make more sense when we look at an actual example. It was the same for the next one as well. So for y is equal to the modulus of f of minus x, x values change to the opposite sign, so the graph is reflected in the y-axis. Then any negative values of f of x are made positive by reflecting them in the x-axis. Now, I personally would actually just prefer to draw the line of y equals minus x, because f of minus x is kind of that, but that's only if you're doing basically a straight line. If you're doing it properly, whatever the function originally was, you're then going to reflect that into the y-axis, because putting a minus in front is a reflection of the y-axis. Then, because we want the modulus of that graph, we're then going to reflect anything under the x-axis upwards. The easiest method for sketching is to draw f of x and then reflect appropriately. Okay, so let's go into some examples. Hopefully it should make more sense what I've just explained when we go through examples. Sketch y is equal to the modulus of f of x for f of x is equal to 5x minus 5. Well, how are we going to do this? So, first thing we're going to do is draw f of x equals 5x minus 5, so without the modulus. And we get a graph like this. You should be able to draw a simple straight line graph. It's from GCSE. There shouldn't be a problem there. Now, we're going to reflect the section below the x-axis in the x-axis. So all of this stuff here can't be on the graph because y is equal to a modulus, so y must be positive. Here we've got loads of negative y values. So, and what happens to negative values when they go into a modulus? They become the positive versions. So they're just going to go into that same position but above the x-axis, like this. And this is what it looks like without the original graph with it. So I did this to show you the original graph, this to show you kind of the difference, and this to show you the final product. In the actual exam, it'd be fine to leave this there so long as you dotted it. Here's another example. Sketch y equals f of the modulus of x for f of x equals 5x minus 5. First, draw f of x equals 5x minus 5, so that's the same as last time. Reflect all negative values in the line y equals y-intercept for this function. So for this function, the y-intercept is minus 5. So values below minus 5 need to be reflected in that line, like this. The actual reason for that is that because it's f of the modulus of x, is at this point when x becomes negative, you see, because it's going past the 0 point, and the modulus of minus 1, for example, is going to be the same, f of the modulus of minus 1, sorry, is going to be the same as f of the modulus of 1. So we're going to have the same point here, and it'll continue for each number, so that's why we get this. And this is what it looks like without the original graph. Once again, in the exam, you could leave this on, you just have to make sure it's a dotted line. And also make sure you label stuff properly. Get y equals the modulus of f of minus x for f of x equals 5x minus 5. So first we're going to sketch f of x again. Once again, it's the exact same. Then we're going to reflect it in the y-axis to give f of minus x. Or you can think about it as drawing the negative of all this. So you could think of it as drawing the graph of minus 5x plus 5. Either way, you get this. This is what it looks like originally. This is the original one with the reflected one. And then now we're going to reflect the section below the x-axis in the x-axis because it's the modulus of the entire thing. So the bit below the x-axis on this black one is going to be reflected upwards to give this orange one. And that's what it looks like without the workings. So again, you could leave these here. You just have to make sure they're dotted and label them. If it's not very clear, you can highlight the one that you're doing as well, because you're allowed a highlighter in the exam. It's a trick I've used. I'm not 100% sure on the rules of actually using highlighters in your workings for maths papers though. As you'll probably know, I sat my A-levels this year, but I didn't sit them because coronavirus. So a lot of the rules didn't work how they normally do with exams. So I would have to check that for you. Solving modulus functions. And it's being slow loaded again. There we go. Solving something in the form modulus of f of x equals n, or modulus of f of x is g of x. So this usually produces more than one solution, because there's going to be a solution for the positive and a solution for the negative. It is useful to sketch y equals f of the modulus of x and y equals n or y equals g of x on the same axes. Consider the different intersects and consider the different parts of the modulus graph as though they are different functions or equations or lines to create a solvable equation for each intersection, and then solve these equations and calculate your graph. Once again, I don't think this is the best explanation for now. It's going to sound confusing, but then once I show you an example, which I'm about to do, it'll make more sense. Wait for it to load. Solve the modulus of 2x minus 4 equals 5 minus x. So the first thing I'm going to do is sketch both of these on the same set of axes. So the red one, I've color coded it, you see, is the modulus of 2x minus 4, and the blue one is 5 minus x. Now, there's my labels. We want to consider the modulus graph as two separate lines to make it easier to solve. So this one is the same graph as y equals 2x minus 4 for x is more than or equal to 0. And this one is the same as minus 2x, y equals minus 2x plus 4 for x is more than or equal to 0. So I've split them into two separate lines like that. You can see you end up with basically the same thing, but this one can go below the x-axis. The other reason it's like that is because the software I used, I couldn't figure out how to make it so it doesn't show below the x-axis. So, but in the exam, you would not draw below the x-axis for this. We want to find the places where the modulus of y equals 2x minus 4 and y equals 5 minus x intersect. To make it easier to solve, okay, I don't like my explanation here, so I'm going to explain it differently. So we don't want to find this point of intersection, because if you look up here, that's part of the same modulus. That's the same curve, line, whatever you want to call it. So this intersection we don't care about. What we do care about is this intersection and this intersection, because they're the points where the lines overlap, they're the points where they're equal to each other. So we want to find a point where y equals 5 minus x and y equals minus 2x plus 4 intersect, and we want to find a point where y equals 5 minus x and y equals 2x minus 4 intersect. So we can set up two equations: minus 2x plus 4 equals 5 minus x, and 2x minus 4 equals 5 minus x. The next thing we will do is solve these equations. The fairly basic equations to solve, you should be able to do that without my help. And and you'll then get x equals minus 1 and x equals 3. If you look up here, there was no y in the original equation. We added those because we were graphing. So you don't need to solve for y as well. Solve the modulus of x minus 2 equals the modulus of 3x plus 4. So you can see for this example, it's going to be slightly more complicated because we have two moduli. So we're going to sketch them both on the same axes like we did last time. So the red one is the modulus of x minus 2, and the blue one is the modulus of 3x plus 4. We want to split each modulus into two lines this time. So done that here. The green one is y equals x minus 2. The orange one is y equals minus x plus 2. Purple one is y equals 3x plus 4. And the black one is minus 3x minus 4. So these moduli make up the original ones. You should be able to see by looking at the two sketches which ones they are. Now, in the actual exam, I would draw the two moduli and label them. And then in pencil, I would label the line that, what was I going to say? Oh, the line I'm using for them, so these lines. And I would put a dotted line in pencil at the end of it to show that the line would continue below that point. We are not interested in where y equals x minus 2 and y equals minus x plus 2 intersect, because they're part of the same modulus. And we're also not interested in where y equals 3x plus 4 and where y equals minus 3x minus 4 intersect for the same reason, they're part of the same moduli. We are interested in the other intersections, which are here between y equals minus 3x minus 4 and y equals minus x plus 2, and here between y equals minus x plus 2 and y equals 3x plus 4. So we're going to set them equal to each other. That minus 3 should be black. And this 3 should be purple. We're going to solve minus x plus 2 is equal to minus 3x minus 4, and minus x plus 2 equal to 3x plus 4, and that will give us x equals minus 3 and x equals minus a half. Again, you should be able to solve them simply. They're not hard. GCSE level. Okay, so that's the end of this video. I hope you found it useful. Like, share, subscribe, give me feedback if there's anything you think I can do to make this easier, more simple, more understanding. And I will see you guys later. Hope you enjoyed the video. Bye!